Topic modeling helps us uncover the main themes that run through a collection of documents. In this lesson, we'll use the Latent Dirichlet Allocation algorithm to find topics in a set of news articles. To do this, we'll first prepare the text, build the structures the LDA expects, and then train the model with GenSim. GenSim is a Python library designed for text analysis. It's lightweight, fast, and built to handle large collections of documents. In our case, we'll use it to create the dictionary and corpus that LDA needs, and then to train the model itself. Let's see how that goes exactly. First, we'll import the required libraries: pandas for loading and working with the news articles, RE for cleaning up the text, NLTK tools for removing stop words, splitting text into tokens, and stemming words, and finally, GenSim and GenSim.corpora for building the dictionary, the corpus, and training the LDA model. With these in place, we're ready to load our dataset and start preparing the text. So let's use pd.read.csv to load the file named newsarticles.csv and store its content in a new variable called data. Don't forget to download the CSV file in advance and place it in the same folder as your notebook document, or otherwise you'll get an error. Okay, when we run data.head, we see that the dataset has 3 columns: an ID, a title, and the article content. The content column holds the full text of each article, while the title column contains the article headlines. Next, using data.info, we confirm that the dataset has 100 rows and no missing values. That means every article is complete. Since our focus is on the text itself, we'll extract just the content column and work with it in the steps ahead. So we create a variable called articles and assign it the content column from our dataset. This gives us direct access to the full text of all news articles. Once we have the articles, the next step is to clean the text so it's ready for LDA. This includes converting text to lowercase, removing punctuation and stop words, tokenizing, and stemming, steps we already covered in the course so far. Let's quickly go over the code so it's clear what is going on. To keep it short and focused, we rely on lambda functions and the apply method once again. Let's look at the first line of code. First, we take the content column in the articles variable and use the string.lower method to convert the text to lowercase. After that, we call the apply method to perform identical operation on every article. The operation itself is described with a lambda function. In our case, the lambda function says, take the input x, which here represents a single article, and return it after applying the re.sub function with our regular expression for removing punctuation. On its own, the lambda handles just one article. By placing it inside apply, pandas takes care of running that same lambda function on every article in the column. Then we keep working with the articles variable, applying each processing step to it one after another. This way, the text gets progressively cleaner and more structured at every stage. So, in the next line, you can see how we remove the stop words and then we tokenize the text. Here, the lambda applies the word tokenize function, which splits each article into a list of words. Finally, we stem. The lambda applies the porter stemmer, reducing each token to its stem, just as we practiced before. Stemming is chosen here instead of lemmatization because we have a large amount of text, and this approach will speed up processing by reducing word forms. That said, if preferred, lemmatization can also be used instead. So, in short, we are using the same operations you've already seen in previous lessons, but now we apply them efficiently to the entire dataset by chaining apply with lambda functions on the articles variable. Cool. After finishing the cleaning process, we can display the articles to inspect them. We see that there are 100 items, each representing one cleaned and tokenized article. The next step is to create a dictionary which will map every unique word in our dataset to a unique ID number. We build it using corpora.dictionary and we pass in our articles dataset to it. This way, each word in the articles gets its own ID, which will later allow the LDA model to work with the text in a structured way. Print in the dictionary shows that we have 8,693 unique tokens, representing the number of unique words in our dataset. Next, we create a document term matrix. This is simply a table that shows which words appear in each document and how often. It's the same idea as vectorizing text in earlier lessons, but here we're using a method provided by the Jensen package. That method is doc2bow, standing for document to bag of words. It takes a single article, looks up each word in the dictionary, and returns a list of word IDs together with their counts. So we use list comprehension to apply this to every article in the list and collect the results into the variable doc term. This way, instead of plain text, each article is represented as a bag of words vector, which is the exact format the LDA model needs. Print in the document term matrix shows that the text has been fully vectorized into numerical representations. To begin modeling, we first decide how many topics we want the LDA model to extract. For this example, we'll set the number of topics to 2. We then create our LDA model with gensim.models.LDA model. This function needs 3 key arguments: the corpus, which is our document term matrix, the ID 2-word dictionary, which maps word IDs back to actual words, and the number of topics we want the model to find. Together, these inputs give the model everything it needs to start discovering recurring themes in our articles. Once the model is trained, we can inspect the results. We do this by calling LDA model print topics, where we specify how many topics to display and how many words we want to see for each topic. The output shows us the most important words that the model has identified for every topic. These words give us a sense of what each topic is about. Since we are analysing news articles, these topics are not very informative. This suggests that we may need to adjust the number of topics, clean the dataset further, or explore the data more to find meaningful topics. In the next lesson, we'll move on to a different method of topic modelling that might help us extract more interesting insights.